Zack from Kid2Kid Tutorials, and today we will be working on perpendicular bisectors with triangles, and don't forget to subscribe. Okay, let's start on our first problem. Find the radius of this image here, of this figure here, given that BC equals 8 and QO equals 2. So BC right here is equal to 8, and QO right here is equal to 2. So, we also know that OQ is perpendicular to BC, given that we have this right angle right here. That indicates that OQ is perpendicular to BC. It also indicates that OQ is perpendicularly bisects BC, because Q here is the midpoint of BC, and we have OQ is a line that goes straight through it. So we know that OQ is perpendicularly bisects BC. So then we know that BQ must equal 4 and QC must equal 4 also, because this whole length BC equals 8. And since OQ bisects it, that means it splits the BQ and it splits BC in half to leave us with BQ, which is half of 8, which is 4, and QC, which is half of 8, of 4 again. So we're given those. Now, OC here, we have all the side lengths of this triangle, if you spotted this triangle, COQ. And we're given this length here, OQ, which is 2, and QC, which equals 4. OC is the radius, so let's try to find that using the Pythagorean theorem. So we have 2 squared plus 4 squared. 2 squared plus 4 squared is equal to C squared, which is the hypotenuse here, OC. So 2 squared is 4 plus 4 squared, which is 16, equals C squared. So that equals C squared. We don't know C yet. So that's what we're trying to figure out here. So 4 plus 16 equals 20. So C squared equals 20. Now, what we need to do is take the square root of both sides, since we're trying to find C, not C squared. So we square root both sides, and we get C equals the square root of 20. And of which, of course, we can factor the square root of 20 out to 2 square root of 5. So C, which is the OC here, is equal to 2 the square root of 5, which is the radius. Now we're going to start on our next problem. But before we start on that, we have to know what a circumcenter and a circumradius is. So what a circumcircle is, so a circumcircle is an imaginary circle that goes around a triangle. And a circumcenter is the center of that imaginary circle. So right in the middle of that imaginary circle around the triangle. And it usually lies inside the triangle. So what a circumradius is the radius of the circumcircle, the imaginary circle around the triangle. So now that you know what a circumcircle, circumcenter, and a circumradius are, we can go ahead and start on the problem. So since we're trying to find a circumradius in this problem, the problem says find the circumradius of an equilateral triangle with side length 18. So first let's draw the circle, because it's asking for the circumradius. And then we can draw the triangle within it. So remember, it's an equilateral triangle. That means all the sides are equal. So all the sides must be 18 then. So 18, 18, and 18. And it needs to be labeled A, B, and C. Now let's let O be the circumcenter for this circle. So what we can do to help approximate where the circumcenter would be is to draw a line through AB, BC, or AC and AC to find where the bisectors intersect. So these are the bisectors of the sides. And we're going to call this point here O. So it might not be exact, but at least you get the point where and how to find a circumcenter. So now we can use O and draw a perpendicular line down to BC. So we can draw a line here and then a line down there to make them perpendicular bisectors. And we'll call this point here P. So if OP bisects BC, that means that both the sides have to be equal to each other. So since side BC is 18, then half of 18 would be 9. So PC would equal 9. So now to find the circumradius, which is OC, we can use the proportional ratio of all the sides of a 30, 60, 90 triangle. So you can see this is a 30, 60, 90 triangle is because this is a 90-degree angle. And since it's not an isosceles triangle, it's an acute right triangle. So therefore, the sides must be 30 and 60. So we can use the common ratio of a 30, 60, 90 triangle, which is 2 divided by the square root of 3. And we have to multiply that by one of the sides, which is PC, since we already know that. So we have 2 divided by the square root of 3 times PC. So PC is 9. So we have 2 divided by the square root of 3 times 9. And then if we simplify that out, we get 9 times 2, which is 18, divided by the square root of 3. And if we rationalize the denominator and all those stuff, we eventually get 6 square root of 3. And we have that as our answer, the circumradius. I hope now you have a good understanding of what a perpendicular bisector is with triangles. And if you don't, be sure to leave questions in the comments below, and we'll try to make another video with examples, more examples this time. Thank you for watching Kid2Kid Tutorials. And if you like our videos, please share, like, and subscribe. Thank you.